Hello, Arsalan. Am I audible? All right. Any doubts from the last class? All right. We'll wait for a few minutes. All right. Then we'll start the class. You can revise till then. All right. In the last class, we learned about what is derivative, right? And we solved few questions using first principle. So what is first principle in derivative? This is limit tending to 0 f of x plus h minus f of x upon h. All right. This is first principle using derivative using first principle. All right. I hope no issues with this. All right, solve one question. Find derivative of cos x using first principle. All right, this is f of x equals to cos x. You just have to solve this one. This is called first principle. All right, I'll give you a few minutes. All right, how we can solve this? This one we can solve by first principle. Very easy. Limit x h tending to 0. This will be cos x plus h minus cos x, right? Because limit h tending to 0, f of x plus h minus f of x upon h is the first principle method. So cos of x plus h minus cos x upon h, this is the derivative, right? So this is limit h tending to 0. This is cos c minus cos d. The formula for that is minus 2 sine c plus d, this plus this. So x plus h plus x by 2 into sine c minus d by 2. So x plus h minus x. So x and x is cancelled. Sine h by 2 whole divided by h. All right. So this is limit h tending to 0 minus 2 sine 2x plus h by 2 sine h by 2 whole divided by h. Now to solve this limit, if you put h equals to 0, this will become sine 2x sine 0, that is 0 upon 0. So this is 0 by 0 form. So to solve this one, this is sine h by 2. According to the standard formula, if I multiply and divide by 2 here, I can get the value of this as 1, and this 2 is cancelled. So I can get limit h tending to 0. So this is sine 2x plus h by 2 sine h by 2 upon h by 2. So this becomes 1. This quantity is 1. So the final answer will be minus sine x, because if you put h equals to 0, 2x upon 2 is x. All right, this is the answer. So what we get from here is differentiation of cos x with respect to x is minus sine x. Is this clear? Arsalan Abdul, is this clear? All right. This was the first definition, definition 2. If f is a real valued function and a is a point in its domain, then the derivative of f at a is defined by limit h tending to 0 f of a plus h minus f of a upon h. Let's write it down. Right here, provided this limit exists. Derivative of f of x at a is denoted by f dash a. All right, let's try to solve the question. Find the derivative of sin x at x equals to 0. All right, so we can write f dash 0 will be limit h tending to 0. This is f of a plus h minus f of a upon h. This is limit h tending to 0. F of a plus h, the value of a here is 0. So we can write f of 0 plus h minus f of 0 on h. Just put the values. 0 plus h, if you put in sign, then sine 0 plus h minus sine 0 upon h. All right. So this is limit h tending to 0. Sine 0 plus h is sine h minus sine 0 is 0 upon h. So sine h upon h, limit h tending to 0 is 1. All right. So this is the answer, f dash 0. Is this clear what we did here? Arslan Abdul. All right, note it down and solve next question. Find the derivative of f of x equals to x square plus 1 at x equals to 2. All right, I'll give you a few minutes, try to solve this. solve this. Arsalan, Abdul. Okay, Arsalan, the first principle says if you have to find out this, then what you can write? F dash 2 you can write as limit h tending to 0 f of 2 plus h minus f of 2 upon h. This you have to remember, all right? You have to memorize this, otherwise very difficult. All Arslan, I think you left the class when I was telling you about this, right? In the last class. Please watch last class lecture, then you will to get this, all right? This is called first principle. So now limit h tending to 0 f of 2 plus h, we have the function as x square plus 1. So if you put the value of x as 2 plus h, you will get 2 plus h square plus 1. F of 2 will be 2 square plus 1. So let's put the values here. 2 plus h whole square plus 1 minus 2 square plus 1 is 5 upon h. Limit h tending to 0. This is 4 plus h square plus 4h plus 1 minus 5 upon h. Alright, so this minus 5, 1 and 4 is cancelled. What we have is limit h tending to 0 h square plus 4h by h. So h is cancelled. What we get is limit h tending to 0 h plus 4. Put the value of h as 0. The answer is 4. So f dash 2 will be 4. Is this clear now, Arslan? And Abdul? No, note it down, all right? Then we'll solve the next question. All right, next question. Find the derivative of f of x is equals to x square plus 4x plus 3 at x equals to 1. All right. Solve this. Arsalan, Abdul. Arsalan, solve this. Two x minus 4. You have to find the answer. Did you just differentiate this? Let's see. So f dash 1 we can write as limit h tending to 0 f of a plus h minus f of a upon h. So a here is 1. So let's try to find out 1 plus h first. All right, f of 1 plus h. So we'll put this value in this function. So this function is x squared plus 4x plus 3. So instead of x, we'll be writing 1 plus h whole square plus 4x. So 4 into x means 1 plus h plus 3. So this is 1 plus h square plus 2h plus 4 plus 4h plus 3. So this is equals to h square plus 6h plus 8. All right. This we can put in here. F of a plus h is h square plus 6h plus 8 minus f of 1. F of 1 is very easy, 1 square. So 1 plus 4, 5 plus 3, 8. Whole divided by h. So 8 and 8 is cancelled. What we get is limit h tending to 0, h square plus 6h upon h. So limit h tending to 0, this is h plus 6. Answer will be 6. Aslan, is this clear or not? This is very important. All right, first principle is very important. All right, note it down. All right. So this was all for first principle. All right, now formulas. All right, these are few formulas that we already deduced from using first principles, and you have to memorize. All right. So derivative of sine x, or first x raised to the power n. All right, there is some power of x. If you have to differentiate that, this is equals to n x raised to the power n minus 1. All right. Second one, differentiation of sine x is cos x. Differentiation of cos x will be minus sine x. Differentiation of tan x is secant square x. Differentiation of cot x is minus cos x square x. Differentiation of sec x is sec x into tan x. Differentiation of cosec x is equals to minus cosec x into cot. This you have to remember, all right? There is no other way. This you have to remember. And if you have any issues in remembering which is the negative, which is not, wherever you see the co is first, cos, cot, cosec will be negative answers. All right. Differentiation of cos x, cot x, cosec x, all are negative. Rest of the functions are positive. All right, note it down. All right, few more are there. Differentiation of e raised to the power x is the same, e raised to the power x. Differentiation of a raised to the power, where a is any constant, positive constant, a raised to the power x log a. Differentiation of log x base e is 1 upon x. Differentiation of log x base a, any positive constant, is 1 upon x log a. All right, write it down. Done with the formulas, Arslan, Abdul? All right. So what is the first formula? X raised to the power n. Suppose if they give you differentiate x raised to the power 5. So read that formula, that is x raised to the power n. So here the value of n is 5. So what does it give us? N into x raised to the power n minus 1. So the answer to this is 5x raised to the power 4. All right, clear? rest are direct formulas, so no need to explain that, I guess. All right, so let's solve one question. Differentiate the following with respect to x. X square plus sine x plus 1 upon x raised to the power 2. All right. You have 2 minutes, solve this one. Right, how we can solve this? If we have to differentiate this, differentiating with respect to x, so x square plus sine x plus 1 upon x square, right? We can distribute this differentiation, all right, or break it into 3 parts. So this will be differentiation of x square plus differentiation of sine x plus differentiation of 1 upon x square. All right, if there are many functions added together or subtracted together, you can break them into different parts. All right, so in the first part, this is x raised to the power n formula, so that is 2x raised to the power 2 minus 1 plus differentiation of sine x is cos x plus here 1 upon x square, so I can write this as differentiation of x raised to the power minus 2. All right, x raised to the power minus 2. So this is 2x plus cos x minus here also x raised to the power something, so minus 2 x raised to the power n minus 1. So minus 2 minus 1 is minus 3. This will be your answer. All right. 2x plus cos x minus 2 upon x cube. Is this clear? Differentiation. Is this clear? How to differentiate this? Very important. Let me say this again. Differentiation is very important in the whole, in the 12th. There is a whole unit of differentiation. All right. Note it down. All right. Next question. Differentiate this one. Ax square plus bx plus c upon under root x. D by dx of xh. Okay, if there is any constant multiplied, you can take that out of differentiation. All right. If you have suppose 5 x raised to the power 5 differentiation of this, All right, any constant multiplied in any function, then you can take this 5 outside. So this will be d by dx of x raised to the power 5. All right, epsilon. All right, so what you can do here is just separate this, break into 3 parts. So I can write this as ax square upon under root x plus bx upon under root x plus c upon under root x, right? So this is a x raised to the power 2 minus 1 upon 2 plus b x raised to the power 1 minus 1 upon 2 plus c x raised to the power minus 1 by 2. So this is a x raised to the power 3 by 2 plus b x raised to the power 1 by 2 plus c x raised to the power minus 1 by 2. All right, now we can differentiate this. So d by dx of this whole, we can differentiate them usually. So this is a x raised to the power n into x raised to the power n minus 1 plus b into n into x raised to the power n minus 1 minus c by 2, right? This half is multiplied, x minus half minus 1. So this is 3a by 2 x raised to the power 1 by 2 plus b by 2 x raised to the power minus half minus 1 by, sorry, c by 2 x to the power minus 3 by 2. What you can write here is 3a root x by 2 plus b by 2 root x minus c by 2 raised to 2 x raised to the power 3 by 2. All right, Arsalan Abdul, this is clear? All right, note it down. The next question. Differentiate under root x plus 1 upon under root x whole square. Differentiate this one. solve this. Arsalan, Abdul. This is very easy question. Differentiation of under root x plus 1 upon under root x whole square. So what you can do here is differentiation of, open this. So this is x a square, so under root x square plus b square 1 upon under root x square plus 2ab, 2 into under root x into 1 upon under root x. So differentiation of under root x square is x plus this is 1 upon x plus this is 2. Now we can break this into 3 parts. So differentiation of x, this is x raised to the power 1. So 1 into x raised to the power 1 minus 1. This is x raised to the minus 1. So minus 1 into x raised to the power minus 1 plus differentiation of any constant is 0. All right, remember this, differentiation of any constant is 0. You can write also derivative of a constant number is 0. All right, so this is 1 minus x raised to the power minus 2. So this is 1 minus 1 upon x square. Clear? Arslan, this is clear? Let's solve next question. X square minus 3x plus 2 x plus 2. All right, differentiate this. Solve this. Aslan, Abdul. Aslan, are you able to understand this or not? All right, let's see. We can simply multiply this. This is x cube plus 2x square minus 3x square minus 6x plus 2x plus 4, right? So this is x cube minus x square minus 4x plus 4. And this have to differentiate. This is very easy. So differentiation of x cube minus x square minus 4x plus 4. All right. So differentiation of x cube is 3 into x square n into x n minus 1 minus 2x minus 4, and differentiation of 4 is 0. This will be your answer. All right, clear? Arsalan, is this clear? All right. Next question. X square plus 1 upon x square whole cube. Differentiate this one. Solve this one, Arslan. differentiation of this function. This we can open up. This is a cube, so x square cube plus 3a square b, so 3a square, so x square square and b, so 1 upon x square plus 3a b square plus b cube. This is the formula for a plus b whole cube. So this we can write d by dx of x raised to the power 6 plus 3x square plus 3 by x square plus 1 upon x raised to the power 6, right? So this is differentiation of x raised to the power 6 plus 3x square plus 3 to x raised to the power minus 2 plus x raised to the power minus 6. Now we can differentiate this very easily. So differentiation of x raised to the power 6 is 6 x raised to the power 5, 6 minus 1 plus 3 into 2 x raised to the power 2 minus 1, so 1 plus 3 into minus 2 x raised to the power minus 2 minus 1 minus 3 minus 6 x raised to the power minus 7. All right, so you have 6 x raised to the power 5 plus 6x minus 6 upon x cube minus 6 upon x raised to the power 7. All right, I hope this is clear. Next question. Arslan, this is clear, right? And Abdul? All right, so now if they give you like question like this, x plus a, how to solve this, where a is a constant? How to see, this is not sine x. If this was sine x, you could have easily wrote cos x, but this is x plus a. So how we can solve this is, if they've given it to differentiate this one, we can easily write the formula for sine a plus b, and sine a plus b is sine a cos b plus cos a sine b. All right, now we can differentiate this because cos a is a constant here. So cos a differentiation of sine x plus sine a differentiation of cos x. So cos a and differentiation of sine x is cos x plus sine a differentiation of cos x is minus sine x. So cos a cos x minus sine a sine x. Is the formula for cos a plus x. All right. Clear? Arslan, Abdul? All right, next question. Sine a plus x upon cos x. Differentiate this one. All right, I'll give you a few minutes. solve this one. See, similar question, differentiation of this. Open this up. So this is sin A cos x plus cos A sin x whole divided by cos x, right? What this will become is d by dx of sin A into cos x by cos x. So this is sin A only plus cos A sin x by cos x, that is tan x. Now breaking the differentiation derivative. Sin A is a constant, derivation of constant is a 0 plus cos A is constant into derivation of tan x is sec square x. All right, so this is the answer, cos A into sec square x. All right, clear? Abdul Arslan. All right, one very important topic, product rule in differentiation. All right, what is product rule? Product means multiplication. If two functions have been multiplied in the question, they have asked you to differentiate that. How to do that? All right, if f of x is a function, and g of x is also, g of x and f of x are real valued function, differentiation of f of x into g of x. All right, if two functions have been multiplied, then differentiation becomes this is equals to f of x into differentiation of g of x plus g of x into differentiation of f of x. All right, if two functions have been multiplied, then take first function into differentiation second function plus second function into differentiation of first function. Write this down. We'll solve this question, few questions, then you'll be absolutely clear with this. All right, just write it down. All right, so suppose in the question they give you differentiate x sin x. All right, now the differentiation of x, and we know the differentiation of sin x, but they have multiplied these two functions. All right, so according to the formula, what we can do is read the formula. If two functions have been multiplied, then take first function, so x into differentiation of second function, so d by dx of sin x plus take the second function sin x into differentiation of first function, that is x. Is this clear, Arslan Abdul, how to apply this formula? whenever you see two functions multiplied, you have to use this formula. Arslan, this is clear? Now x into differentiation of sin x is cos x plus sin x into differentiation of x is 1. So what you get here is x cos x plus sin x. This is the answer. All right, note it down and solve another question. X cube sin x upon cos x. All right, differentiate this one. I'll give you a few minutes. Aslan, just few questions you have to solve. All right, you can leave after 15-20 minutes. All right, no issues. Just solve few questions with this formula. All right, so how to solve this one? See, this is sin x upon cos x is tan x, so x cube tan x. So again two functions have been multiplied. So what we can do is take the first function, differentiation of second function plus second function to differentiation of first function. All right, so x cube differentiation of tan x is sec square x plus tan x into differentiation of x cube is 3x square. All right, so this will be your answer. Taking x square common, we can get x sec square x plus 3 tan x. All right, Arsalan, this is clear. Abdul, solve another question. E raised to the power x sin x plus x raised to the power n cos x. Right, I'll give you a few minutes. All right, how to solve this one? First, differentiate this, then this, add both, right? So differentiating this, what we get is take the first function, differentiation of second function, plus second function, differentiation of first function. So this is e raised to the power x cos x plus sin x e raised to the power x. Now differentiating this one, x raised to the power n cos x. So this is x raised to the power n differentiation of cos x plus cos x into differentiation of x raised to the power n. So this is x raised to the power n minus sin x plus cos x into n into x raised to the power n minus 1. Add these two and that will be your answer. Clear, Abdul? Next question. E raised to the power x, x plus log x. Now let's solve this one. I'll give you a few minutes. let's solve this. Abdul, how to solve this one? Differentiation of e raised to the power x into x plus log x. So if this is the first function, this is the second function, what we can write is first function into differentiation of second function plus second function into differentiation of first function. So this will be equals to e raised to the power x. Differentiation of this, differentiation of x is 1 plus differentiation of log x is 1 upon x plus x plus log x into differentiation of e raised to the power x is e raised to the power x. All right, you can take e raised to the power x common, can get 1 plus 1 upon x plus log x. All right, this is clear, Abdul? Or what you could have done, you could have opened the brackets and then differentiated individually. All right, you could have just multiplied like e raised to the power x and x plus log x. Just open the brackets, so e raised to the power x plus e raised to the power x log x. Now differentiate this and this, then add. You will have the same answer. All right. Next question. X plus sec x, x minus tan x. Try to solve this one. All right, how to solve? Abdul, have you solved this? How to solve this function and this function is multiplied? Doing right. I'll give you 2 more minutes. All right. All right, let's see. This is the first function, this is the second function. So differentiation, if we want, so this will be x plus sec x to x minus tan x and whole of differentiation. So what we want is first function into differentiation of second function plus second function into differentiation of first function. So what we'll have here is x plus sec x, differentiation of this. So differentiation of x is 1 minus differentiation of tan x is secant square x plus x minus tan x to differentiation of x again is 1 plus differentiation of sec x is sec x into tan x. All right, now you can multiply also. There is nothing common, I guess, right? All right, just multiply. So this is x minus x sec square x plus sec x minus sec cube x plus x plus x sec x tan x minus tan x minus sec x into tan square x. I don't think you can simplify any further, right? So this will be your answer. This is 2x and I don't think anything else is common here. All right, Abdul. All right, then absolutely right. So I hope this is clear. All right. Yeah. In the next class, we are going to learn division rule or quotient rule and few more things, and this chapter will be finished. All right. All right. You can start the NCERT also. All right. No worries. You can solve as many questions as you can. All right, then. See you in the next class, Abdul. Take care. From 27, your finals are starting. When is the maths exam? Not sure. All right. So please check the dates. All right. We'll finish this chapter in the next class. That's for sure. All right. Don't worry. All right, then. Take care, Abdul. All right.